All right, well, we should be live. Welcome to Questioning Christianity, a channel where we try and help you connect the Christian story to life's deepest questions. I'm Dan Patterson, and you're joining us tonight for what should be a really lively conversation. This is our QC Conversation series where we try and bring on a guest who really knows what they're talking about to field many of the questions that you send into us through our website and through our social media channels. And surely one of the biggest questions that people tend to have, perhaps barriers towards belief in God or taking the Christian story seriously, comes down to our knowledge of the natural world, or the advance of the scientific endeavor, and alternative explanations for who we are, how we got here, and whether God has been buried by science or somehow fits in with that whole picture. And so given that I am not a scientist, but more a theologian, it's great to be able to invite someone and put them in the hot seat so that they can field all of your hardest questions. In this episode, we're calling Does Nature Point Towards a Creator? And so our special guest for this evening is probably not new to many people who are in the area of science and religion. He's done quite a number of online things, as well as written a couple of books, which we'll talk about later. But he is a cosmologist and a theoretical astrophysicist, which is quite a mouthful to be able to get out there. He's based in Australia, teaches out in Western Sydney Uni, and it's my honor to invite on the channel Dr. Luke Barnes. How are you, mate?
I'm very well. Thanks for having me.
Great. Well, we are really excited to dive into a conversation really in a little bit of your area of expertise. But for most people, when they hear those words, let's say you're at a dinner party or you're out at the pub and someone says, "Oi, what do you do?" And you say, "Oh, well, I'm a cosmologist and theoretical astrophysicist." Most people would just smile and nod and think politely, "I have no idea what that means." So what on earth do you do?
Well, there's a joke that if you want the conversation to continue, you say I'm an astronomer, and if you want the conversation to end, you say I'm an astrophysicist. That's just giving a bit of the game away.
Yeah, I think people just feel nervous.
So
They're remembering all of their high school physics classes and how they barely made it over the line. So worried about where the
well,
conversation will go.
yeah, there's a couple of ways it goes then. It's kind of interesting to me which way it goes because some people are just like, oh, they've got to tell you about this time when they saw the stars. They had this sort of mystical experience. I was out in Tanzania in the middle of nowhere. Or my favorite one was I was this guy who was a British submariner. He was in a submarine and they were sort of tailing some Russian sub up in the Arctic. And at night, lights off, quiet. You're not allowed to do anything.
Yeah.
So all you could do was just grab a beer and get up on the deck, rug up, and just look at the stars. So yeah, I get a lot of different responses.
You'll have to collate those stories and put them into an anthology at some point.
Absolutely, yeah. That one's one of my favorites.
So what is, though, theoretical
what do I actually do? Yeah, no, that was the question. So broadly, I'm a theorist. Within astronomy, there's the people who specialize in building the telescopes. There's the people who specialize in using the telescopes and the data. And then there's the people who specialize in doing the theory side of things, taking the laws of physics and trying to understand what we see in the data. And when I started my PhD, the head of the school famously said that the instrumentalists were the defenders and the observers were the midfielders and the theoreticians like myself were the strikers of the soccer team. And apparently everyone
that
he was a
cool.
theorist. Everyone else got offended by that. Well, what to tell you? We're the strikers. You're the anyway. So my job is not so much using the telescopes as sort of the equations, and in these days, we have a powerful tool to try and solve those equations, which is computer simulations. So I'm specifically aiming at questions like how do galaxies form, how do they change once they've formed, and more broadly on this topic of what's life's place in the universe, and especially in relation to the fundamental properties of the universe.
So basically, if the Starship Enterprise ever really does get off the ground, you're the kind of person we'll find on the deck, wearing one of those officers' uniforms, answering all of those weird questions.
Yeah, and in a crisis, I'm nowhere to be seen. So I'm just all the theoretical answers. Yeah, exactly.
Now, this doesn't exactly sound like the kind of thing you just stumble into at an expert level. So what really got you interested in the study of nature as a whole? And for you, maybe growing up more around a Christian faith as well, where does the God side of things factor into that?
Funny enough, I think it was dinosaurs that first got me interested. I was some sort of nerd growing up. I think we all know that, but I think more of a dinosaur nerd. But then was just good at mathematics, and then at the end of high school, did the last 2 years did physics at school, and thought that was really interesting. And then didn't quite know what I wanted to do at university, but as part of the degree that I started, I did first year physics and went, oh no, I want to do this. So I changed to do a physics degree, and then on the way through discovered that I mean, the whole of physics is fantastic, but actually applying it to the universe and to the universe as a whole was just really sort of magnificent. That these laws we understand down here can help us understand what's up there. So followed up to do a PhD in all of that.
Wow. And what's it kind of like then being a scientist who believes in God? I mean, in your academic experience within universities, maybe more in the professional side of application scientists as well, the different fields. How have you found that community? Are they relatively open to you speaking publicly about your beliefs, or is it a little bit more of a bizarre, difficult, fraught environment? I'm curious about your experience on that end.
It's never been fraught particularly. So I'm certainly not the only one. I'm not the only person who's ever, only astrophysicists. There's plenty of astrophysicists I know who are theists in general and Christians in particular. And it's the sort of thing where, and sadly this happens less and less, but all the interesting stuff at any conference happens at the pub after the conference. It's both scientifically and just sort of more generally. You start talking.
I think that's
about
almost a common rule
everything.
for every conference.
Just it all happened. The day sessions are just so we roughly know what to talk about down at the pub in case something interesting comes up. But yeah, it'll come up in that, and it's met with usually just sort of a bewilderment. Like it'd be worse if I said I was in it, I studied astrology or something. That would be infinitely worse. So it's not quite that bad, but.
Yeah.
I've had some interesting conversations, certainly not fraught in any particular way. When you know how to do science, you realize that, there's a whole lot of other beliefs that just don't matter as much, as long as you're interested in understanding how the world works, applying the evidence of our senses and the best mathematical theoretical knowledge we have, then, game on. Let's just get busy studying the universe.
Yeah, I know some of the guys that I chat with pretty regularly who don't really believe in God, but would like to think that they're scientifically literate, at least. Maybe have this cultural assumption that there is some kind of conflict between science and God, or it's difficult to be a scientist and believe in Christianity. I'm curious where you think that perception has largely come from.
Yeah, I get it. It's sort of weirdly it's just in the air around.
Yeah.
There's some guy I played cricket with who was just out in Western Sydney, and he's a tradie, never been to university or anything like that, but just sort of came out with that one day. And unfortunately, I was just in the next conversation over, and I wanted to just run in and take over, but I couldn't. Yeah. So the funny thing for me is, as I sort of I grew up in a Christian household, Christian background, but then being more and more interested in science, I kept hearing that there's this conflict between the two. And when I looked into it more, a lot of that was centered on young Earth creationism. So I wrote not that long. I wrote an article for sort of Premier Christianity Unbelievable, just about my sort of history and that being brought up in that, but then realizing that it was neither the right way to look at the Bible or to look at nature. Once that issue was a non-issue, actually, it's really hard to pin down what the conflict is supposed to be. So many of the arguments. So I just started reading. Thankfully, one of the things that helped me quite a bit was one of the first books I ever read on. It was called "The Ways of an Atheist." It was written by an atheist. It was supposed to be a defense of atheism, and it's still behind me. I don't know why. It's dreadful. It's just one of the worst. It's really awful. It's just a terrible book, terribly argued, completely ignorant. Anyway, what that at least gave me the first impression of, oh, okay, it's not that all the smart people are over there and all the idiots are over here, so to speak. So so I tried to look for a higher quality of atheists. So I read, it's behind me as well, Bertrand Russell's Why I'm Not a Christian.
Yeah.
And then just tried, Dawkins behind me, and more recently trying to read Sean Carroll and various other thinkers. And, it just strikes me that the arguments, once you've got does scripture make claims that are in direct conflict with science about how the world works? And I don't think it does, mostly because I don't think it makes a lot of claims about how the world works. Is not what it's about. So I'm not a young earth creationist. Once you've got that out of the way, it doesn't, the rest of the arguments are very tenuous, and some of them are pretty awful. In fact, you have to misdefine what faith is, or you have to try and invent some sort of straw man religious sort of person who this, that, and the other. And a lot of the arguments are just really terrible. So that was my sort of growing realization that, so, having heard all this about, there's this conflict between science and God, of looking for it for the last, 20 something years, and just not finding it.
Yeah, we might jump into that a little bit later. I think maybe the perception of what some of my friends have expressed to me is that it's almost as though we didn't have a way of explaining the world. And so we used some sort of religious story or supernatural explanations. But then we, through science, have been able to unlock many of the mysteries of the universe, the causality and the physics. And so now we can answer a whole lot of things when it comes to understanding the phenomenon around us and why things happen the way that they do. And so maybe God just isn't as necessary as an explanation anymore, that whole God of the gaps idea. But we'll jump back into that a little bit, because I want to maybe dive into the focus of what has been a lot of your specific research. And I've got a couple of publications here that you've contributed to. One is a lovely hard copy version of A Fortunate Universe. And this is actually a really interesting book. This is kind of spells out a little bit the fine-tuning problem, or fine-tuning as it's known in the scientific literature, and what you should make of that. And what's interesting about this is you wrote it with someone who was a research partner of yours, Geraint Lewis, who's not a Christian, right? Or not a believer in God. Spell out that experience of writing a book together around this fascinating phenomenon that we know about the universe, but having very different end takes on what that points towards.
Yeah, so Geraint was my honours supervisor. He was one of my lecturers coming through at Sydney University, and then was my master's supervisor, and then later just a colleague. We just started working together on various things. When I having done a undergrad at Sydney and knew Geraint there, and then he helped me in my application to do a PhD at Cambridge. Then when I came back to Sydney after a postdoc in Switzerland, another long story, no, short story, postdoc in Switzerland, came back to Sydney University, two things kind of converged. I'd heard a lot about this thing called the Theanthropic Principle, fine-tuning, all that sort of stuff. And while I was at Cambridge, actually, we were encouraged to do a talk to their public astronomy nights. And they do those most weeks in winter. And so I thought, this would be good. I'll sign up to do that, and then I'll read a whole bunch of stuff about it. As a part of doing that, I discovered not only is there a whole lot of popular level books on it, but there's like genuine scientific research. There's all these scientific papers that a lot of the popular level interactions on both sides just obviously weren't aware of. They were still reading, books from Paul Davies from the 1980s, which are perfectly fine and great books, but not quite up to date.
The data moves on, yeah.
Yeah, well, the theory moves on as well, but that's another story. Gets more sophisticated, I should say. Yeah. So at Sydney, I got asked, I gave a talk on this topic and to the student society. Then, sorry, I seem to have frozen. Oh, I'm back.
Yep, you're back.
Okay, so I gave a talk at the Student Physics Society, and then got asked to give a talk to the astronomers, because they were for various reasons. And so we had a sort of special seminar for it, and 40-minute talk, and then an hour and a half of questions afterwards. Not just to me, like everyone amongst ourselves, just discussing what this what this fine tuning of the universe for life thing is and what it means and what we're supposed to do with it. That never happens. It's usually sort of you have a talk and then 2 questions and then everyone goes to lunch. So
You relate
that
this
was when we
story
knew we
actually
were
in
onto
one of the
something.
in one of the chapters of this book, where it's like a dozen
Yeah,
different responses to this fine tuning problem, I guess, or fine tuning phenomenon.
yeah. So Geraint was in the audience. He was thinking about writing a book and thought, all right, let's write this book together. We could write about the science of this, and so that's how it started. And a couple of years later, we had the book. So we decided we'd write the first. We basically wrote the first 7 chapters together, and then the last chapter takes the form of a conversation about what all of this means.
Yeah. Yeah, fascinating, super interesting people to pick up, and certainly is probably more focused largely on the data and what it means, and trying to understand the scientific theory that you're interpreting it through. But the other one that's maybe a little bit more directed towards Christians is in a series of pieces called "The Story of the Cosmos: How the Heavens Declare the Glory of God." And you co-wrote an article in here, or a chapter, on the fine-tuning argument. So not so much the concept of the fine-tuning problem or phenomenon as we see it in nature, but then turning that into an argument for the existence of God. So maybe just by way of definition, there's probably a ton of people watching this who just are not at all familiar with what fine-tuning is, and certainly they're not familiar with the fine-tuning argument. So would you be able to just offer some spelling out of those two ideas?
Right. So the fine-tuning itself goes like this. As we study the universe, we try to understand the sort of patterns underneath it, the laws of nature, and they usually take the form of equations that tell us if you know how the universe is at a certain time and how it's changing, then you can sort of predict how it's going to be in the future.
Yeah.
And so you try and use this to explain the way the universe works. As we boil it down and down and down to the simplest stuff that we can find, we come up with a set of equations that are sort of as deep as we are at the moment, as deep as we can get. And in those equations, we find that there are certain numbers that have to go into the equations. So predictions come out of the equations, but these ones have to go in. We just have to measure them, and then they're input into the equations, which is not what you want. You want predictions. You want things to come out of the equation so you understand them, solutions and such. These numbers are things like how much does an electron weigh, and how strong is the sort of electric and magnetic force, electromagnetism, and how strong is gravity. And in terms of the overall expansion of the universe, sort of how fast is the universe expanding? Well, what's the overall density of the universe on average? How much stuff is there in every bit of the universe? So there are in total about 31 of these numbers. We don't know why they are what they are, because they're on the bottom floor. And so one of the things that scientists have done for the last sort of 40, 50 years is to ask a different question, which was, what would the universe be like if these numbers had been different? So if there had been a universe in which the electrons were all a bit heavier or a bit lighter or whatever, what would happen? And that's the sort of question you can answer with theoretical physics. It's sort of exactly what theoretical physics is. If the universe obeyed this law, what would it be like? And what we found is kind of interesting. A lot of those numbers actually don't make much difference at all, to be perfectly honest. They're for some very weird things that aren't seen very often, except in particle accelerators, neutrinos and such.
Yeah.
But there's a core of about maybe 10 of those numbers where of the range of values they could have had, of the range of values that we can put into our equations and make sense of, if we start to move throughout that range, suddenly we discover that the universe that would have existed won't support the complexity that life needs. The simplest way to think about this is stuff won't stick to anything else. So, for example, if the universe expands too fast, for example, if there's something in it called the cosmological constant, if it's too large, then the universe expands really quickly. Stuff won't stick together because literally everything is too far away from everything else. All right, so you're made of a whole lot of protons, electrons, neutrons, all that stuff stuck together. But if every proton finds itself surrounded by a couple of million light years of empty space, nothing's going to happen, right?
It's a
Even
lonely
if it could
existence.
happen. A very lonely proton. The other thing you can ruin is if you ruin the way, the forces by which those processes stick together, and in particular, if you make it so that the falling apart processes are sort of allowed and encouraged, so to speak, then you get a universe where you just can't build anything. It's like it'd be like a Lego set where nothing sticks to anything else. There's very limited options as to what you could do.
Yeah.
So these sets of facts, which were rather sort of surprising and alarming, no one saw them coming, or there's a lot of confusion about what on earth to do with these then and now. It's called the fine tuning of the universe for life. So the thought is think of all the options as a sort of dial, an old school radio dial or something. If you want an interesting universe where anything sticks to anything, you've got to get that dial in just the right sort of a relatively narrow range for these 10 or so parameters. That's fine tuning.
So is that's not just one dial, that's all of those 30 or 31 numbers have to be dialed right.
Not quite.
Okay.
As I said, a lot of them are kind of actually irrelevant. This is one of the things that some people get wrong.
Cool.
So, for example, there are particles called neutrinos.
Yeah.
We've seen them in experiments, but they interact with ordinary matter like us extremely weakly. And what that means is, if they're heading towards your hand, almost certainly they just pass straight on through. They don't interact, unlike the light, which hits the surface of the hand and bounces off. There's all sorts of parameters that describe them because they're in the universe, so we've studied them and looked at them, but actually a lot of those you could change, and because they go through the hand anyway, it doesn't really matter how they go through the hand. So there are a lot that don't matter that much. It's just this 10 or so out of the 30 that are really quite remarkable, how finely tuned you've got to get it, and how dramatically you ruin the universe if you don't get these ones right.
That might be the title of the next book, either The Lonely Proton or Dramatically Ruining the Universe. Yeah. You can come up with the theoretical physicist's kind of guide for that. But on this then, how do you get from that observation that there are these 10 or so parameters that are finely tuned and necessary for life to be possible anywhere in the universe, to then getting an argument for God's existence? Why do some people think that this feature of nature points towards a creator?
Yeah. So far, everything I've said is some stuff that Geraint would agree with, right? That's the stuff we agreed with on the book. So then the argument, well, my favorite, I think I should look this up, but I think I got this from Alistair McGrath, who said he was presenting about fine tuning, and someone said to him afterwards, "Look, I'm not religious, but something weird is going on here." Some quote like that. I heard it once, and now I can't find it again. But there's something intuitive about sort of seeing the hand of design here. That I don't want to sort of immediately jump into sort of a technical presentation. There's something about this particular fact that was very, very unnerving to a lot of the scientists and physicists who discovered these particular facts. So one of them was Frank Hoyle.
Fred Hoyle?
Fred Hoyle.
The British.
Sorry, I got mixed up with Frank Tipler, who wrote a book on...
Frank's a good name too, but it's good. Something. But
I knew that was wrong. It came out
the
of
Big Bang guy, the guy who coined the phrase "the Big Bang" on the BBC
right. So
radio.
Fred Hoyle, the building in which you sit, in which my office was in Cambridge, the PhD office was the Fred Hoyle building. So I should probably know that.
Get it right. Well, they'll revoke
several
your
of his
PhD.
Books behind me. Come on. All right, if we can edit that bit out. No, it's live. Fred Hoyle. So, massive name in astrophysics in the 20th century. One of the major names who worked out how stars burn. What nuclear reactions actually power stars. There's a very famous paper. So it's Geoffrey Burbidge and Margaret Burbidge, husband and wife team, Willie Fowler, and then Fred Hoyle. This paper, B squared FH, who worked out how stars work. So as part of that, what he worked out was, given the known properties of carbon, if you take what they knew about carbon, we're talking the sort of 50s and 60s here, if you take those properties and you, on the basis of those, you say, how hot would a star need to be in order for it to produce carbon? The answer was way too hot for any of the stars we actually have in our universe.
Sure.
And so the question is, well, how on earth does carbon happen? And Hoyle thought he might know the answer. If there's a special property of carbon that basically gives it a sort of quantum backdoor, a quantum shortcut to making carbon, so to speak. The reality is a whole bunch of equations I can't get into, but that's as good as
I'm just going to keep smiling and
definition.
nodding, just like the person at the party.
Yeah, should have seen the stars. There's what he worked out was, if carbon had this special property, then there would be a way of making carbon, and that's the stuff we're all made out of, and all the stuff bigger than carbon as well. Otherwise, it would be a sort of pure hydrogen and helium universe, the two simplest elements which don't do very much. And on the basis of that, not only did he work out that this property needed to be there, he worked out the sort of, he told one of his experimenter friends, Willie Fowler, where to look for it. Basically, there was a very specific property. He told them exactly the experiment to do to find it, and there it was. And what he said was, it looks like a super intellect has been monkeying with physics, because there's all these ways to get it wrong. And yet our universe picked one of the few ways to get it right. So
that intuition to kind of infer design just based on these observations.
Yeah. So just the thought that, supposedly you get quotes from people like Bertrand Russell, actually, saying things like, we're just an accidental collocation of atoms. People saying it's just third rock from the sun. There's I think, an intuition, if you're an atheist, that there better not turn out to be anything particularly remarkable about the universe. This was why Darwin was supposedly the thing that was going to get rid of design, because, any old bunch of stuff that can replicate will eventually form animals and all that sort of stuff.
Yeah.
Right. It better not be the case that, there's something really rare and remarkable and interesting about the amazing things we see around us. This better be just the sort of stuff you'd expect in any old universe. And unfortunately, this fine tuning seems to go wildly against that. There's suddenly a whole collection of ways that the universe could have been. We have a sort of collection of possible universes we can compare our universe to, sort of a background against which we can see. So this is the idea of, we're the third rock from the sun around an average planet, as a way of saying we're just nothing special about us here. If you look at the sun amongst all the suns, it's just all the stars, it's just another star. If you look at the Earth amongst all the other planets, just another planet. Suddenly you've got a chance to go look at our universe against all these other universes, and oh no, that's gone badly. Ours has some remarkably rare properties that most universes don't have. So that, I think, is the intuition. You see, the design intuition kicks in when we see an outcome which is rare amongst a big set of possibilities, and what's rare about it is what it does, what it achieves, what happens at the end of the process, because then it doesn't look like anything sort of at the front end could be aiming for it. So the watch that, famously Paley says, if you're walking on a heath, you find a watch. One of the reasons why you see design there is because it's not like any of the basic laws of metals and rocks and winds and waves and all that stuff care about keeping time. That's something a mind would care about. So our universe does something interesting, but it's not because it's mathematically unique or anything like that. There's no reason why the laws of nature care about stuff that can think and act and have a meaningful moral life. So that seems like not the sort of thing that you would expect in just any old naturalistic universe. It's the sort of thing that needs a mind to aim at, because it knows the way things can end up at the end of the day. It involves
Yeah.
planning and intention and all the sorts of things you associate with the mind.
So that's kind of an intuitional way of arriving. And I mean, there's passages in the Christian story in the Bible that seem to resonate with that. I think of the poetic rendering in Psalm 19:1 that the heavens declare the glory of God and the skies proclaim the work of his hands, or the Apostle Paul in Romans 1:20 speaking of this way that God has made his existence plain. For since the creation of the world, God's invisible qualities, his divine power and might, have been clearly seen, being evidenced by what has been made, so that people are without excuse. And this is certainly maybe a discovery that somewhat accords with that prediction of there being some fingerprints of design within the universe itself. And there's something of a formal argument that philosophers of religion draw from this. They try and take this intuition or this observation, put it in a syllogistic form. The fine-tuning of the universe is either down to chance, necessity, or design. It's not because of chance or necessity, therefore it's by design. And so exploring those other options then, given that you've got this fine-tuning in the universe, just as a scientific observable fact, what are some of the critiques of this intuition of yours, or of the fine-tuning argument from secular thinkers who don't like the idea that this might be evidence for a creator?
Yeah, so like you said, there's sort of 15 or 20 of these responses in the book. So there's a whole host of them. The way I like to think of the argument, and I think it sort of cuts off some of those objections before you start, is actually that it's justifying, in a sense, the design intuition that we've always had. Human beings have always had. So you look at the world around you, you see the amazing things, and you think someone must have thought this through. And what I think it shows is that the progress of science hasn't change that at all. What the atheist needed to be true is that underneath the amazing things around us, it turned out that the universe was actually boring and typical, and this is what you'd expect any old bunch of stuff to do. And that wasn't obviously true when you're looking at a bird flying past, but it's just the laws of nature playing out. But then when you find the fine tuning, you realize actually, it seems well designed all the way down. I think that actually forestalls a number of complaints, but two of the main ones are actually we just need to keep doing science. The thought being that, we don't know what these numbers are right now, but give us some time and we'll know why they must have been what they are. They couldn't have been different. And so what we've really been doing is just like, thinking, well, what if pi had been different? What if, pi r squared and all that, what if pi had been different? And you can mess around with that and have a whole lot of fun. But ultimately, pi is actually a necessary fact. So necessary, truth, the value of pi. So you're not really doing anything if you do that. The problem with that, well, let me do the other one and then we can. So the other one being, that's the sort of necessity side of things, that we're changing. We think we can change these quantities, but really we can't.
So the idea that maybe in the future, because this is genuinely one of the things that a friend brought up a few weeks ago at the local watering hole. Awesome. He's like, you might be at the point where the data for you look towards that being evidence for God, but we might discover some deeper principle that's the reason why it has to be that way. We just haven't discovered that yet. So give science time and it will come up with an alternate explanation. Yeah. That kind of response. Is that what you mean?
Yeah. So eventually, so I've been saying, well, what if the electron was heavier? And tomorrow science might be like, well, the electron has to be that heavy and can't be different. So I don't know what you were wasting your time on.
So that's sort of, these features just have to be this way, and so it doesn't require any further explanation. Yeah. Mm-hmm. And what was the other one?
The other one's the multiverse, where you said necessity and chance. So maybe our universe, won the lottery. So if we could zoom out on reality and look across the universe on an enormous scale, way bigger than just the size of our universe, the observable universe, then maybe we'd see that actually there's lots of different universes or different parts of the universe. It doesn't really matter where there's lots of different values of these constants. And if you go far enough that way, you'll find heavier electrons. If you go far enough that way, you'll find lighter electrons and all these sorts of things. And so if there's enough of these other possibilities out there, then the right combination will turn up somewhere eventually, just via chance. And of course, the only sort of people who ever get around to asking the question, I wonder why we have these constants of nature, are the ones in the bits of the universe where there are the right values of the constants of nature. So that's the multiverse objection. That maybe the assumption that's gone wrong is the assumption that this is the only universe.
Yeah, sure. And so given, I remember seeing there was one comedian, I can't remember his name, but an American guy chatting with Stephen Hawking, and he's like, so this proposal of there being, infinite number of universes, does that mean that there's a possible universe out there in which I'm smarter than you? And Hawking quipped straight back, yes, and also one where you're funny, but that's the kind of idea, right? Yeah, if there's enough universes out there, we just happen to live in the one where it is finely tuned for life, and there could be a near infinite number that aren't hostile to life entirely, and that would
no one's there going, I wonder why I'm not in a fine-tuned universe. There's no one there to worry about.
And that's kind of the internet response you see with the whole water and puddle analogy as well, right? The reason we're asking this question, how the water finds itself perfectly in the puddle finds itself perfectly in the shape of the hole in the ground. And they're saying, wow, isn't it amazing that we're designed so perfectly to fit this hole? Well, no, you fit the hole because that's the parameters that require you to be this shape. And so they say that's like the Theanthropic Principle here. If we wouldn't be asking this question unless it was fine-tuned for life. So largely end of story. Multiple universes, we happen to be the lucky ones. All right, so walk me through then why you think those aren't good explanations.
So the first one, necessity. So the question we're trying to answer is there anything remarkable about this universe? Is there anything interesting and noteworthy about it, which might lead us to think that there's something beyond it? Does it need a sort of extra explanation than what we see or what science might think of as at the deepest level? The way you answer that question is by just going as deep as you can. So on one level to say, okay, look, we might find some science in the future which overturns that, it's precisely to say, well, we've never explained the design that you thought there was in the universe. So, the world around us looks designed, life looks designed, famously. And the great hope was, and actually Dawkins is really clear about this in A Blind Watchmaker. The first chapter of that's really remarkably good on this. He explicitly is handing the bulk of the problem off to physics. As long as physics is simple down at the bottom, he thinks simplicity is enough, that's not right either, but he's explicitly handing that problem off to, as long as it's just average, typical stuff moving around that makes us, then we don't have to worry. It won't look designed, and then we're okay.
Yeah.
So it's precisely is to say, look, everything that we've observed, and all the way down to the deepest level of science that we know, has a universe that looks unbelievably designed. And so that response is to say, maybe the next thing we learn will be completely unlike everything we've learned so far and completely overturn it. That's the sort of explanation that we're going for.
When you pull out necessity, that's what you mean.
Yeah. It's to admit that theism has won every battle so far.
Yeah.
The other part of that is, there's several things to say about this. One of them is necessity. It's that way of necessity. Science doesn't deal with necessity. That's not a scientific category. That's, if you know your philosophy, that's modal logic, right?
Yeah.
For some fun. If you understand modal logic, please tell me.
Yeah.
Well, it's must be rather than just is. So if I say, so what modal logic is roughly, and the point I'm making is, so if I say my name is Luke, that's true. If I say 2 + 2 = 4, that's true as well, but it seems to be true in a different way, in a different mode,
concrete way.
Hence modal logic. Well, In a way that, so the way that you would say this in modal logic is, my name is Luke is contingently true. It's true in this world, but not in all possible worlds. It could have been different. It's very easy to imagine a world in which it was different. You can ask your parents what other names they were thinking about before they named you, and
Let's be
all that
honest, you're
sort
a
of stuff.
Star Wars baby, aren't you?
No, my older, well, my dad's a pastor. My older brother's name is Matthew. And my younger brother's name is Paul.
Okay, so you get the
So put
Gospels.
that
All right,
together.
sorry. I thought
My
maybe
other,
the
I
nerdery ran deep.
have 3 brothers. The other one's name is Graham. Who knows what that? Logically, it should be Mark or John. We got sidetracked. Okay.
Yes, we did.
Uh,
So necessity. Yeah.
so 2 + 2 = 4 is a necessary truth. It's true in all possible universes. It can't possibly be false. There's no point, back in 1983 where someone decided that 2 + 2 = 4, but it could have been 6. And I don't mean the symbol 2 and the symbol 4, or the word 2 or the word 4. I mean the mathematical thing 2 and 2, and you mathematically add them, you mathematically get 4. The thing that represents, not the tokens we use to write that down, and that's mathematics. And in physics, we study how this universe is. So there's all sorts of equations and all sorts of books behind me. They do a great job of describing our universe, but you never get any statement like, and therefore the universe must be this way and could not possibly have been different. It's not just, it's the sort of claim physics has never made. Physics would have to become something else in order to say that. It's just a completely different category of statement entirely. If physics ever made that claim, it would just have become metaphysics, or something's drastically changed, because all the laws of nature are just, if the universe is like this, then that would explain the stuff we see around us. So that's why we think the universe is like that. But must be like this is just a completely different category entirely.
So to bring that down practically, so you're chatting to your friend and they say, well, maybe we'll just discover something else. Is it fair to say, but we make our decisions now based on the data that we have at hand, and the best way of making sense of that as it fits now? And if it changes in the future, sure, it changes. But I don't think it's healthy to deny what looks like reality right now, simply because it might change at some undisclosed point in the future.
Yeah. If they want to acknowledge that the best scientific information we have points towards a creator, then so be it. It might change tomorrow. But the thing that has to change tomorrow is not just what physics knows, but the kind of thing that physics is.
Yeah.
Which is just a drastic kind of change.
Yeah.
In
that's
practice,
helpful, but
if a theory came along tomorrow that explained the electron mass, we would look at that theory. Are there free parameters in that theory? And what we're doing when we change these numbers is the kind of the easiest way to investigate other ways the universe could have been. We want to go and look at, like, the sun against all the other stars. We want to look at our universe against a whole bunch of other ones. The easiest way is to change these numbers, but we still want to do that even if it turns out one of those numbers couldn't be changed. We'd want to change mathematical structures and equations and all that, which is more difficult, but we'd still want to do that sort of thing.
Yeah. All right, well, let's jump to the second one, because I think this is probably the most popular thing that I've bumped up across. So you raise, what do you make of this fine-tuning evidence? And people say multiverse. Just multiverse. Yeah. It's almost a reflexive action. So why not? Why not this multiverse that we live in, where we can find a quantum mirror and move between them and create Stargate or Star Trek episodes of our own? Why don't you think that's a meaningful response to the fine-tuning observation?
Yeah, I spent last week talking to various radio stations about the multiverse in the context of Marvel, because that Doctor Strange movie's out.
Yeah.
So here's my take on this. Often you get the response from philosophers of religion or whoever that we don't have any good evidence that the multiverse is true, and it's sort of, even amongst scientists, there's debate about, is this thing science at all? In particular, because for almost all multiverse theories or ideas, you'll never get direct evidence of another universe.
You can't go there to observe it.
Yeah. So, I mean, there are things in our universe which are unobservable. So you're made of atoms. Atoms are made of protons, neutrons, and electrons. protons and neutrons are made out of quarks, but you never get a single quark just on its own. You can't just sort of look at a quark. So in a very strong sense, it's unobservable. However, at the very least, it's here, and I can do some sort of experiment to try to work out what the properties of a quark are. Literally, these other universes will never, almost certainly, or for almost all models, will never get anything that brings any evidence of them to us here today. But I think there's actually a stronger line of argument than this. What we're trying to do is, again, to work out our universe against a background of other universe to see whether there's anything interesting about our universe.
Yeah.
If you want to say actually fundamentally what reality is like is a multiverse, some sort of great collection of stuff. Well, okay, we looked at our, life forms against a backdrop of just ordinary stuff like rocks, and we're like, okay, life forms are incredible. And then you could look at the Earth against the background of, all the other planets out there, the sun against all the other suns, and then we look at our universe against a whole bunch of other possible universes. And now what you want to do is to say, okay, the one where we compared the universe against all the other possible universes, that didn't go very well. I'd like to do that again, please. So you try to say, oh, maybe what's fundamental is actually a multiverse. Well, if you're following the logic, what we now want to know is why this multiverse rather than some other multiverse. So we'd like to take our multiverse and compare it to a bunch of other ways the multiverse could have been. The problem with that is we don't have the slightest clue how to answer that question. So it's taken a question we can get some sort of handle on using, what our universe against all these other possibilities. We can get a real proper handle on that. We can throw all of fundamental physics at it. How do we solve these equations with different values of the laws, with different values of the constants? Sorry, I've tried to answer this question with supercomputer simulations of galaxy formation. Other people have done it for the structure of atoms, the structure of stars. Fred Adams has done some great stuff looking at that. Stars turn out to be pretty robust, actually. It's quite interesting.
I'll know that if I ever try to go toe-to-toe with a star.
If you make a star, it's good and solid. They're very hard to blow up. Let me put it that way. We've attacked that question, and we have a good handle on, here's the range of possibilities, here's our universe, where are the interesting ones where anything can stick to anything else. Well, it's actually a very small little area amongst the whole. If you want to replace that question with, okay, well, what about this multiverse? We're just immediately lost. We don't have any sort of standard theory of the multiverse. We don't know what its laws are at all. We don't know what the parameters are in that law to then go and change them to work out whether a life-permitting multiverse is rare or common. We have almost no chance of proper direct observational evidence to tell us which model is at least the one that describes our multiverse that we're in.
Yeah.
And, even the ideas, the sort of theories of the multiverse we have, a lot of them are they're what a physicist calls a toy model. So we talk about modeling with equations and all that sort of stuff. And when you have a very, very simplified model, which can be very useful for sort of illustrating certain points, but when you have a very simplified model, it's called a toy model. It's not supposed to represent reality. It's supposed to show just like a proof of concept. The models of the multiverse we have are of that sort. They have all sorts of problems just producing any predictions at all to get any sort of probabilities out of them, for example. So I think my answer to that is, look, if we had the laws of the multiverse, we'd be doing this conversation about those laws. Are they special? Are they rare? Is there anything interesting going on with it? We haven't got it. So all you've done is taken a question we can answer and is interesting and tried to replace it with one we can't answer. It's the sort of equivalent of taking your ball and going home, just refusing to play the game.
Yeah, it's interesting. And is there any reason to think that, let's say there were multiple universes, how do we know that they're not all fine-tuned for life as well? That whatever is generating these universes may set all the parameters to be able to have life. And so you've got some finely tuned universe generator as well. So that's kind of helpful.
There are some toy models. Even some of the toy models need fine-tuning. So
yeah. I'm curious as to then your take as someone who's thought about this deeply. Do you think this is a good reason to believe in God?
Yeah, I think it is. And at the very least, it, it should make you profoundly uncomfortable if you're a naturalist, if you think that nature is the only thing. As part of that, this was one of the sort of growing realizations as to why actually so much of the um, God versus science debate was so sort of boring to me. Boring is not the right word. No, it's so sort of unconvincing. Was when it boils down to it, and when you actually get someone who has enough sort of philosophical, an atheist who has enough philosophical sort of nous to realize what the difference is. What the naturalist is ultimately saying is that when we get to the ultimate laws of nature, the universe just is. There's a certain chain of explanations in the universe, and they get down to the ultimate laws of nature, and they stop.
Yeah.
That's almost a quote for something Sean Carroll said. So
Yeah.
it's this. You've, as part of that, you've got to convince yourself that you didn't want any explanation other than that's what the laws of nature are, and that's the way the universe is, and that's it. Now, if you're thinking entirely on a sort of higher level, that all sounds great. We don't need fairies down at the bottom of the garden. We'll just have nature,
Yeah.
nature, laws of nature, science, that'll explain everything. Once you start looking really down at the bottom and thinking about what it would mean for an explanation to just stop on an equation or something, and then that's it. That's all you get. That's reality. Um, it should then be profoundly uncomfortable for you to find that there is not a unique, very far from a sort of unique way the universe could have been, and the way ours has turned out it looks like as Fred Hoyle said, not Frank Hoyle, that was his brother. Fred Hoyle said the universe looks like a put-up job. It looks like some quote super intellect has been monkeying with physics. So at the very
Super
least,
interesting.
I think it should make you very uncomfortable if you're a naturalist. And I think there's a good argument to be made there that if you're at least open to the idea that what's deeper than matter is mind, that will actually do some explaining of why matter is the way it is.
Yeah. And I mean, you've seen some of that movement in figures like Antony Flew, the sort of philosopher, British
Hmm.
philosopher, and in even Christopher Hitchens, his comment that the fine tuning argument, this teleological line of reasoning, a design line of reasoning, yeah, it was the most troubling for him as an atheist. Yeah, it's the
Hmm.
one that had the most punch for perhaps pointing towards there being something more. So that's really interesting. I wanted to throw a comment at you that was made by, I guess, a colleague of yours in a distant way. So Ard Louis is a theoretical physicist at Oxford. I think he handles a lot of the research students there. A
Hmm.
relatively young guy, but he was on The Story of God, the Morgan Freeman documentary exploring big ideas in the universe and our thoughts about God's involvement and how science has progressed, and kind of plays a little bit into that conflict narrative between science and religion.
Hmm.
And so he's walking somewhere in Oxford with Ard Louis, and Morgan Freeman, I think, was expecting him to agree with that thesis. And Ard Louis turns around and says, actually, the more we study the universe, the more it points towards God rather than away from him. I'm curious, as someone who is in the field, what do you make of a statement like that? Is that just religious wishful thinking, or is he
Hmm.
driving at not just a fine tuning problem? Are there other maybe arguments for God's existence or features of the universe or discoveries of science that are interesting? And we'll restrict you down to like a 5 minute on this one.
In 25 words or less, yeah.
Yeah.
I think one of the remarkable things is that uh, the reason why, you know, the belief in God is almost universal. If you look over the whole of human history, all of human cultures, there's got to be some mind behind all this sort of stuff. And the reason is because we see order around us, the sort of order that things left to their own don't seem to put together. Um, and it goes very deep and very big, and as far as we can see, there's a way the universe is put together, which seems to be the product of an orderly mind. Now, there's also some ways the universe acts where you might start to think, ancient Greek style, maybe the gods are having a fight or something. But fundamentally, there's this order behind the scenes
Yeah.
and the night sky is one of the most sort of powerful reminders of that. Just keeps going round. Um, if that's the reason why you think there's a God, it's in the order, not necessarily in the sort of the breaks away from what seems like order. If God is there in the as sort of laying down the plan of the universe and guiding the universe as it goes, what you'd expect to see is the harder and deeper you look into nature, the more order you would find. And if you have that view of God, then the progress of science is precisely finding more order in the universe. It's if we couldn't understand the universe, if it was completely irrational, that's when it would be hard to think that there's a mind behind it. But to find just rationally understandable order, deeper and deeper and deeper, as deep as we go, is entirely consistent with the idea that there's a God. So there was a sort of, I don't know how this happened. Again, we said that at the start. Where has this thing come up in the zeitgeist? But it's entirely backwards. Somehow we got convinced that if nature was orderly, that means that there's no reason for that order other than nature itself. And how that switch happened, because it's completely illogical once you lay it out. How that switch happened, I don't know. But once you've understood the sort of explanation that God's supposed to provide for the universe, the more we understand it, the more rational order there is for us to discover. The more, as we try to understand the universe rationally, we find a rationality there waiting for us.
Mm.
The more it should point you towards God.
Yeah, I love that. The orderly nature of the universe and the human mind to rationally unlock its secrets. You know, the two kind of things that I remember sort of C.S. Lewis summing up a lot of the historians of science and questioning why was it that modern science, sort of, Francis Bacon's methodology largely took over in a Christianized Europe. And they said, well, because there has to be this belief in a lawgiver, that men became scientific because they expected law in nature, and they expected law in nature because they believed in a lawgiver. And so a lot of that early movement in modern science being driven by people who believed in God, believed in the Bible, and saw the necessary base beliefs as well as then the motivation in God's command to make creation fruitful to get on about the scientific endeavor. So interesting observations. I'm curious. So this kind of argument, though, what theologians, I guess, and philosophers have often called natural theology. What can we learn about God's existence and nature just simply by studying the natural world around us rather than God's specific acts in history, special revelation? That really only points towards a vague concept, perhaps, a vague theistic concept or belief in a God. For you personally, what's driven you more towards believing in Jesus as making that God known in human history?
Yeah, well, that's another very long, a long story. But the thing that I keep coming back to is, against the a backdrop of a world run by certain, rules and scientific laws, natural laws. The way for God to show, God's hand is to do something only God can do. So, there's this, and I think it's a bad definition of a miracle as a violation of the natural order. Well, it's God's universe. The fact that he usually runs it with such astounding precision and orderliness that we can use equations, beautiful equation, not just any old nonsense, but the best maths we have to describe it is something incredible. To then sort of pull something out above that order. So there's actually, you just quoted Lewis. There's a wonderful quote from his, which is, that sort of God writ large. In for some people, God is written in sort of writing that's too large to see in nature, and so to do the same sorts of things on a small scale. The example he gives, I think this is in Miracles, um, is God causes the rain to falls on lush soil. It grows into grapes. The grapes are picked and squashed and ferment and eventually turn into wine. And so from time immemorial, God has been turning water into wine. And once he did it quicker, just so we'd know who it was. But it's the same thing. So just the idea that that's, if God were to turn up, if whatever the intellect behind the universe is were to turn up, that would be the calling card. Then sends you out to look whether that has happened. And you can look through all the sort of miracle claims. It's not that it's not that we especially privilege certain ones. You just try to rank them by the most likely. With a background assumption that this sort of thing could happen. You're not ruling it out ahead of time. And I think when that happens, the resurrection of Jesus of Nazareth comes out miles ahead of anything else. In terms of if it happened, you would then expect it to be the sort of turning point of history, the launching of the largest human movement that ever happened in the history of the universe. And there's one miracle that fits that.
Matt, I love that. Appreciate that. Hey, we'll close this out, and really enjoyed being able to have just a wide-ranging conversation, both about your own personal story, but also this data. I'm just curious if there's anyone watching this who's teetering on the edge of, can I really have a rational understanding of the universe and believe in God? Is this really worth considering? What might just be a point of advice for them?
Buy my book? No. That's my advice for most people most of the time. Again, either one is. I don't get anything from that other one actually, though. So no, this book.
The hard copy one. Yeah, we'll make sure.
Yeah, definitely. I think. Yeah. So the path I followed was that all these popular level arguments, when you really dig in and find out what Christians actually believe. So, my book, like Stephen Barr, there's a whole bunch of wonderful sort of physicists and astronomers and scientists more generally, Francis Collins, to actually find out what they believe about God and about nature. John Polkinghorne, Alistair McGrath. I think you sort of realize so many of these popular level, there's this conflict between God and science just dissolve. There was nothing there to start with. They just completely fall apart in your head. You're wondering what you're supposed to be looking at in the first place. Yeah. So that I think delve deeper into what these scientists who are Christians actually believe.
Yeah. Super helpful. Super helpful. Well, we've got a short video on our channel just around has science disproved Christianity? We've got a little interview back from Christmas with John Lennox exploring can a scientist believe in sort of the Christmas miracles and the virgin birth. So a couple of different spots people can jump into for more info there. Luke, it's been an absolute pleasure to have you on, and I really appreciate your thinking and research in this area. And hopefully, I'm sure a bunch of our listeners will love diving into your books too.
Thanks very much.
No worries. Well, thanks for watching another episode of our QC Conversations. If you like the content, please do go ahead and subscribe. Follow us on socials. If you've got questions that you want answers to, then please send them in to us, whether through the website at questioningchristianity.com or through various social media channels. We'd love to be able to do up more of these episodes each month, bring on a guest who really knows what they're talking about to sit in the hot seat as Luke has today. It's been great being able to be with you today. And as always, truth invites questioning. So if you have any more questions, here at Questioning Christianity, we're all about connecting the Christian story to life's deepest questions. Thanks very much, and we'll see you.